Part 4. Odd and even functions. Even functions are symmetric about the y-axis. In terms of Math 30-1 and transformations, this means that f of x equals f of negative x. Remember, replacing x with a negative x in a function causes a reflection in the y-axis. Examples of an even function are something like y equals x squared. So if we sketch the graph of x squared, okay, it looks something like this. You guys know what x squared looks like. It's the basic parabola. Okay, so it's just like that. But now let's prove that this is an even function. Now, usually you look at the exponents and 2 is even, so typically even. But let's just prove it. Okay, so we need f of x to be f of negative x. Okay, well, if we approach this like trig identities and just mess with one side, okay, we know that the function is x squared. Okay, so the function x squared, so if we want negative x, so we put the negative x squared. Okay, well, negative x squared is just x squared, which is back to the original function again. So that works. I don't know how many people ever get excited about this kind of identities. So if we do it this way, so f of x is just x squared, because that's what it was. Okay, and then just follow that down. Look, x squared equals x squared, and it works that way. So you can do it either way. You guys get to decide. I kind of like using this one. Like, we're not doing formal identities here, so if we manipulate both sides, it's not a problem. Okay, so either way, x squared equals x squared. This is clearly an even function. Now, we don't have to test for odd functions for this guy because you can't be even and odd at the same time. Should make sense. Okay, an odd function, on the other hand, is a function such that f of negative x is the same as negative f of x. Okay, another way of saying this is f of x equals negative f of negative x. And what this simply means that the original function can be reflected over the x-axis and y-axis at the same time and look exactly the same. While the second is easier to visualize, like this guy is easier to visualize. You have your original function, and then you have the negative on both spots, and you remember from Math 30 that this guy here, the negative, that flips it over the x-axis, the negative on the x flips it over the y-axis. So it's easier to visualize, but the math for the second one is more challenging. So when we're asked to prove this, we're going to stick with the first one. We're going to stick with this guy to prove all the math. So if we look at this next guy, the example of an odd function is x cubed. And so let's just sketch that really quick. So x cubed kind of looks like this, and then like that. Okay, so that's x cubed. It's got that nice inflection point right there. Okay, we've talked about those at length. So if we look at those, the idea is for this to be an odd function, this has to work. So f of negative x has to be the same as negative f of x. Okay, so remember, f of x was just x cubed, so this is going to be negative x. We replace the x with negative x cubed, and that's supposed to be the same as negative of the original function, so negative x cubed. So we work this out. Okay, so a negative cubed is negative, so this is going to be negative x cubed, no brackets, and that negative just multiplies by the 1 in front and just makes negative x cubed. Hey, wait a sec, those are the same, so this is an odd function, which is great because we kind of said it was at the beginning, but it's nice that it actually works. Okay, in odd functions, the points with the positive x values are simply rotated about the center to get the points with negative x values. So there's the center of the graph. If you take these guys and just rotate them around, you end up with the bottom part. Okay, awesome. So that's that. So examples. Determine whether the function is even, odd, or neither. Now remember, you can't be even and odd at the same time, so if it's one of them, okay, then you don't have to check for the other one. If it isn't the first one you try, you check the second one, and if neither of them work, then of course it's a neither odd or even function. Okay, so we have a look at this guy. Look, x to the 6th, like that should tip you off that it's even, or at least to try the even part first. So remember, the even part was f of x has to be the same as f of negative x. Okay, so let's see if that works. So the original function is x to the 6th. Okay, this guy here is negative x to the 6th. So if that works out, that's 6 negatives and 6 x's. So x times x times x 6 times, and negative times negative times negative 6 times. Well, that is positive x to the 6th. Well, x to the 6th equals positive x. They're the same thing. So this is an even function. The function... This is even. Awesome. So now let's try the next one. Okay, so this guy, look at that. That's x to the 3, and there's an x to the 1. So I'm thinking that this would be an odd function. But you know what? Just for the fun of it, let's try even. Okay, so if this is an even function, okay, so then f of x should equal f of negative x. So the original function, x cubed plus 1 over x, should equal, okay, so that's going to be negative x cubed plus 1 over negative x. All right, well, that's going to be negative x cubed minus 1 over x. Okay, so does that look the same to you guys? Okay, well, no, it is not the same. So this is not even. Awesome. Okay, so now we check odd. So remember, the odd functions were f of negative x was the same as negative f of x, sorry. Okay, so we try that. So f of negative x, so that's just going to be negative x cubed plus 1 over negative x. And negative f is just negative in front of the whole function. So x cubed plus 1 over x. Okay, so let's see. Negative x cubed is just negative x cubed, and then that negative sign flips up, so it's minus 1 over x. Okay, if we distribute that negative in, we get negative x cubed minus 1 over x. Oh, wait a sec, those are the same. So this is an odd function. Odd function. Okay, perfect. And then the last little bit. Okay, if the following is a graph for the positive x values for f of x, graph f of x for the negative f values if f of x is an even function. Now remember, even functions are symmetric about the y-axis, so that's just going to reflect over here. Okay, so let's see, that point's about there, this point is about there, that guy is about there, and we kind of go into the corner, so this looks like this. Okay, that would make it symmetrical about the y-axis. I know my pen is kind of thick, so it doesn't, not as much space there, but that's the idea. Okay, to be an odd function, remember we have to flip it all the way around the origin. Okay, so for this to be an odd function, we simply, okay, so let's see. This guy here, so he's 2 and about 3.5, so it's going to be 2 over and 3 and about there somewhere. Okay, this minimum is going to be at like 3.5, and who made these things? Geez, I tell you. I'm kidding, I could have changed that, but I didn't. Okay, so 1, 2, 3.5, and that guy is 3.5-ish again. Oops, 1, 2, 3, yeah, 3.5. 1, 2, 3.5, 1, 2, 3.5, so kind of about there, and then again into the corner. So this kind of looks like this, down, up, and then back in. So that's close enough. You get the idea. That's what makes it an odd function. and we are done this section. So please do the the formatives and the summative assessment, and let me know if you need any help. I'm always here. You have my numbers. Talk to you later.